Greetings everyone and welcome to the video. Today I'm going to be talking about household power, and that's going to cover several things including surge protection, shock protection, calculating power usage and things like that. Technically this is both a standalone video, as it doesn't need to be watched in conjunction with anything else, but it's also related to my server farm videos that I've been making, and this was all brought about by my planning to set up a server farm when I get back to the Philippines. One thing I found out quickly while I was doing some research is, while there are a lot of similarities between how things are done in the Philippines and how things are done in the US here, there are some differences, and these can be somewhat critical to to a couple of things: how I hook things up, safety considerations, surge protection, things like that. It's not to say it's better or worse. It's, in some cases, it's just different. In some cases, it's quite similar. It just means that in certain instances, I'm going to have to modify my approach to match what's done in the country. The moral here is to both understand how your house wiring works and what the code requirements are for in the country you're working in or building in or whatever. Let's get to it. Let's talk about electrical requirements, how they might relate to a server farm, even though it could be for anything you're hooking up, any piece of sensitive electronic equipment. First things first, I need to make a disclaimer. I am not recommending that anybody work on their own house wiring. Electricity is dangerous. There's a shock hazard. Like I say, it's dangerous. My recommendation, if you want stuff done with your household wiring, is to hire a skilled professional. Someone who's certified and licensed in the country you're in, has a good deal of experience, and knows what they're doing. So don't touch the electronics or electricity. Hire a professional. End of disclaimer. So let's start discussing how household wiring works in the Philippines. There are some differences that if I'd been aware of these differences, I would have been a lot more vocal in my objections when the contractors were building the house. The problem was, however, though, that I was there for the initial... you shovel the first shovelful of dirt for the foundation of the initial kickoff of the build project, but I wasn't retired at the time. This was many years ago, and I had to actually get back to the States to get back to work. So I did miss a good deal of the build process. Also, a couple of times when I offered comments or suggestions, I ran into opposition, let's just call it. Not just from the contractors. At the time, the better part of valor was to back off and assume they knew what they were doing, which, not a bad assumption, but again, if I was doing things, I would have done things a little differently. But that's a lessons learned. So basically, most homes or houses, non-industrial buildings, are pretty much the same from the pole down to the main circuit box. It's after the main circuit box that we seem to have some divergence. And things get a little fuzzy. Even with the Philippine Electric Code, I'm still reading through it, and a lot of things I noticed last time I was back in the Philippines about the house wiring, well, again, not something I would have done, but they're not specifically or strictly against the Philippine Electrical Code, so yeah. I will say that the house wiring is one place where if you don't specify it in writing in any of the documentation, this is a place your contractor is probably going to try and save some money. And you'll see what I mean as we get into it. But again, having a better understanding now of how the whole power situation works in the Philippines, live and learn, I now understand some of the electrical problems I've been seeing in the house. And we'll probably go into a couple of these. It's nothing major. Again, just like I say, it's just not how I would have wanted to do things. Anyway, let's talk about it. I do want to state up front that this is from memory. When I was in the Philippines, I didn't go around pulling off circuit panels or looking under the hood or anything like that. So what I'm doing is basically from things I remember from things I worked with there. So to begin with, there are two basic configurations for household wiring. And again, this is non-commercial, non-industrial properties in the Philippines, at least that I have seen. One of them is more prevalent in the more populous regions, the city, the suburbs. The others more on old construction and generally out in the rural areas or the barrio. So let's talk about the second one first, the one you find in older construction out in the barrio. Basic electricity comes from the power plant. It's stepped up to a really high voltage, mainly because high voltages can transmit electricity over great distances with very little loss. But when it gets into the city, it needs to be stepped down. When it gets into your neighborhood, it needs to be stepped down again. And finally, what's in your neighborhood needs to be stepped down for your household usage. From my reading and my understanding, at least in my neighborhood, the high voltage coming in is 13.2 kilovolts AC on those lines at the top of the poles, and then that goes down to your transformer, which converts it down to 240 volts AC. Now, in the rural and older construction, you have a non-center tap secondary with 240 volts AC at the top and neutral at the bottom. And this is what comes down into your circuit panel. Like I say, this is the simplest form of wiring. It's two wires. It's often referred to as single phase or single phase two wire or something like that. And like I say, mainly rural and older construction. On newer buildings in more residential areas, they use what's called split phase or single phase three wire, which is basically the use of a center tap transformer where you have neutral as the center tap of your winding of your secondary winding of your transformer, and you have 120 volts at the top and 120 volts at the bottom, and these are both 180 degrees out of phase with each other. And to get 240 volts, you take it across the two hot leads, and that gives you your 240 volts AC, which is common here in the Philippines. There are a few issues with this when it comes to wiring plugs. Well, they're not really issues. I mean, I got to stop saying that. I consider them issues, but it's just the way they do things here. Anyway, let's onward. All right, so my local setup is the single phase three wire or split phase, as sometimes it's called, coming into my house. So I have three wires coming down from the pole, 120, we'll call it 120 volts positive, 120 volts negative. That's sort of a misnomer. They're both 120 volts and they're both 180 degrees out of phase. So when one's negative, the other's positive, and vice versa. And then we have the secondary of the transformer center tap, which is the neutral line coming down. These all go into an electric meter outside the house. And then there's a short run from the electrical meter down to a main disconnect box. I think I'm using the right term there. This is where the main breaker that shuts the power off to the entire house is located. Definitely on the main breaker box there is a ground, because I remember the pole getting driven in. I don't recall if the ground goes all the way up to the meter. I do need to say that the initial wiring for this house, we had temporary wiring which came from a pole like half a kilometer away. So there may be some disjointed areas in our setup. Again, something I need to look at when I get back. Like I said, I'm working from memory here because, like I say, for the first couple of years we had temporary power, and then finally in the last visit to the Philippines we got the pole and the own transformer and then the permanent power setup. So coming out of the main cutoff, we have a main distribution panel inside the house. I'm pretty sure in addition to the two hot leads, we have the neutral running there. And then there's also another sub panel in the extension which was built after the house was completed. And Again, the two hot wires and the neutral running back there, and I'll have to look at those panels to see if they actually have grounds. I believe the main panel, because we had temporary wiring before, it does have a ground. I'm just not sure where it ties back to neutral at. So off the main panel, we have all our switches and lights. I will say for heavier appliances like on-demand water heaters or the in-room air conditioners, we do have, it is a multi-wire setup where you, in addition to the two hot leads and the neutral, you have a ground. But for your standard outlets, the ones I've pulled out of the wall and looked at, there's just two wires, and these are your two hot leads, and they're taken across the two pins of the outlet. If an outlet in the house has a grounding pin, it's not hooked up to anything, because most of the outlets are just the two-pronged variety. Again, this is one of the things I would have at least wanted to ground or the neutral run to all the outlets, but that's not the way it is. Same with the lighting. You got the two hot phases going to the lights. You got a switch. One of the interesting things I noticed, now it's been a few years, but when it rains or lights in the garage tend to flicker. Actually, technically it's a carport, but they tend to flicker even with the switch off. And that's because there's two hot leads going up to the light to get your 240 volts. And if there's some sort of ground developing somewhere when it gets moist, and that's what's causing these lights to flicker. I mean, if it was like we do in the US with the one hot lead and that's where you put the switch, you wouldn't have this issue. But it's something you need to work on and get fixed at some point. So that's, basically how our setup is. Again, from memory, I am pretty sure there's a ground in the house's main service panel, and I know there's a ground in the disconnect box, but I just don't know where they hook into neutral. In theory, they should all hook together in the disconnect box outside the house, but we'll see when I get a chance to take a look. The next thing I want to talk about is a bit of a safety thing. It's the surge suppressors that suppress basic fluctuations in the voltage going up on your line. There's several things that can cause this. Anytime one of the air conditioners kicks on or off, that causes a small surge. The water heaters, they cause a small surge. We've got a washing machine. Plus, anything the neighbors have can cause small surges, although we don't have that many neighbors. The other big thing for surges, besides issues at the power company, are lightning strikes. One thing I want to say about if you buy these extension cords with surge suppressors in them, if lightning strikes anywhere close to your house, they're not going to do you any good, because they'll get fried immediately. Your best bet in that case would be if the transformer up on the pole absorbed the voltage. But if it's miles away, you're okay. If it's cloud to cloud, you're probably okay. It's just if it hits the ground or any of the wires near your house, yeah, these surge protectors, in spite of what they say about them being lightning proof, aren't. Yeah, if lightning is a couple miles away, they might be lightning proof. Anyway, a normal way for a surge protector, if you get like these extension cords with built-in surge protectors, they have a ground pin and a neutral pin and a hot wire, and your surge protector, when it feels the surge, it shunts the surge off to the neutral or the ground wire, depending on how the surge protector is set up, and keeps it from reaching your device, which is usually between neutral and the hot line. However, what I have in my outlets is two hot lines, no neutral, no ground, so I need to get something called a two-prong surge protector, because the three-prong ones are going to try and send stuff to that third prong, which isn't hooked up, and it isn't going to do any good. They do make two-prong surge protectors, and they work, but they're not as effective as the three-prong ones. And the principle there is because your two hot lines are 180 degrees out of phase, they're opposite each other, you can shunt the surge between lines through the surge protector. Yes, it does work. This doesn't work as well as shutting the stuff off the ground. But yeah, if you're going to get it in this type of setup, what I have with my plugs, I need a two-prong surge protector if I'm going to use a surge protector out at the outlet. Now, there are a few things you can do to get around this issue. Use the more effective three-prong surge protectors. I could pull new wires, including the ground wire. That could be expensive, and it is a cement house, so they go through conduit everywhere, but I'm not sure how easy it will be to pull them. If I could get a snake through or a fish tape, yeah, maybe. That's one possibility. It's kind of expensive one. The second possibility is to find an earth ground somewhere close. Well, my office workspace is up on the second floor, so that's really not practical. I mean, yeah, I could drive a grounding rod into the earth outside and run a wire up there, but yeah, not really practical. I could hope that some of the plumbing actually goes to earth ground, or maybe some of the rebar or something. I could check that, and then that would be a shorter wire run. However, I think probably the solution I'm going to be going with, because it is available in the Philippines, is a whole house surge protection, which actually goes in your main circuit panel. There's several varieties. Eaton's I found that it's available in the Philippines. Some of the others maybe not so much. Square D, I believe, is also available, and they make a whole house surge suppressor that goes in the panel, but they recommend you use that with a Square D panel. But I think that's the solution we're going to be looking for here, because again, you've got the neutral and the ground in the panel, and you can shunt the surges off there, and it should protect your whole house. So that's, again, I have to look at things, but that's probably the way I'm going to go in this case. Next thing I want to talk about, GFCI breakers or outlets, ground fault circuitry interrupt. You can put in a 3-pronged outlet and make it a GFCI outlet. And GFCI, in spite of what a lot of people have been telling me, does not require a ground to work. It measures the current difference between the two legs. And if there's any difference, it assumes that something's going on that shouldn't be going on one of the legs, and it trips off. So yeah, they all have a third prongs, at least the ones I've seen, and I might install one out in my office, mainly for the added protection. And again, it has a third prong. Ground is not required for this to work properly. I mean, another option for GFCI is a circuit breaker with GFCI built in that would be in your panel. Again, same thing, it monitors both legs, and any difference in current, it trips. And that would protect the whole circuit. I'm sort of torn. I'm going to see what's available for breakers, but I'm probably going to use a local GFCI outlet in my office just for the added protection. Okay, that was fun stuff that people, when they're talking about how much power you're using and stuff, don't usually talk about. Let's talk about how much power we're going to use. So from Ohm's law in the power equation, power equals current times voltage. So we've got 250 volts RMS, that's AC, 15 amp circuit breaker, 14 gauge wire, that's all good. This equals about 3.6 kilowatts available on the circuit. However, the single outlet in my office is shared with the guest bedroom. And in reality, you should only run about 80% on your circuits. You don't want to overload them. You don't want to have too many of them running too high. So again, 80% we'll use as a mark off. Now, thinking about the bedroom, it's a guest bedroom. There's an entertainment system in there, a TV, and I think a Roku or something like that. People can have cell phone chargers. There's actually a regular cooling fan in there. That's probably a bigger load than the cell phone chargers of the entertainment system, especially when it powers up. The air conditioner and the on-demand water heater are on their own circuits, so they're not an issue. The only other thing that might be an issue in there is the hair dryer. There is a hair dryer because it's got its own bathroom. There's a hair dryer in there, and that uses the heater, so yeah, that'll draw some power. But those are things I got to worry about in the guest bedroom. Calculating the 80%, I figure I've got about 2 kW to play with. So I was thinking about my power usage, and these are estimates. I'm going to need to measure the actual power itself at minimum, idle at maximum. But I'm going to have my three servers. These are all going to be mini computers. I'm going to estimate 60 watts between the three of them. I mean, under load they'll be higher, but anybody who's worked with servers knows most of the time they idle or run it low. It's very rare they ramp all the way up. I've got 2 monitors. I was going to say 60 watts for them because they're two older ones, but I actually replaced one of the older ones that burned out with a newer one that uses less power. So I'm going to call that 40 watts. Laptop itself, I'm going to call 100 watts. Again, the average usage here, I got the Wi-Fi router from the internet service provider. I'm going to give that one a 20 watt. I got a couple of switches. I'm going to give those 30 watts for the two. Probably another 30 watts for the printer. And I've got my own fan there too, so 30 watts average power, but it's going to have a high startup. Yeah. So I think I'm going to be well within my 2 kW that I'm estimating for my equipment. Like I say, when I get there, I'll actually do some power measurements to see what the stuff actually draws. But until then, this estimate should be good for future planning. All right, physical layout is going to be something of an issue. There is only a single outlet with well, there's 2 outlets, a single plate with 2 outlets on it. Again, they both have ground plugs on them, but they're not grounded. And counting up my devices, again, you got the 3 computers, my laptop makes 4 computers, the monitors, the printer. Oh, one thing I forgot about, I've got an audio mixer. Yeah, I'm estimating I'm going to need a minimum of 11 outlets. So that would be 2 extension cords with 6 outlets, 12 outlets. I think 14 would be better if I could, or even 16 if I could find an extension cords with 8 outlets. Or the other possibility is to get an extender and push it into the outlet itself, so I get a couple more outlets that way also. One thing I'll say about extension cords, sometimes they get a bad rep, people saying they're unsafe. They're only unsafe if you do not take their voltage amperage into consideration when using them. Using a light extension cord to plug in a big old fan, just, it's going to get hot. That's just the way it is. So extension cords are fine as long as you can maintain them out of people's way, and as long as you make sure they have enough potential for voltage amperage to meet the needs of anything you're going to plug into them. Like I say, where you really run into problems is older extension cords or cheaper extension cords that don't have much of a power rating and people trying to run the same stuff off of them. So that's another thing, is to verify the current all your extension cords can take. And as I said, I really need to measure the power of everything that's plugged in. Minimum, average, maximum, that kind of stuff. But yeah. Okay, that's about it. We're sort of finishing up this subject here. Again, this is all strictly theoretical. And again, I do not recommend you messing with your own electronics or electrical stuff. Hire a trained, certified professional. But these are just some things you want to consider when you're getting ready to add more instruments or equipment. I'm going to be adding more computers, a couple of switches, some routers, wireless access points, although they're going on a different breaker in a different location. Again, cement house, need those wireless access points. But yeah, there's a few more things when I started looking at that the people really need to consider, and it's all based on how your house is wired. And this is, like I say, I'm doing this from memory. I think I covered everything I need to cover, but when I get there and I take a few panels off, pull a few more switches out. Oh, one thing I will say, and this is sort of what issue I have with the contractor. We were supposed to have some 120 volt outlets available, and they did this by running a separate ground into the outlet and then using one phase in the ground to generate 120 volts. There is actual resistance between ground and getting back to the source, and there's going to be power issues. It's not going to work. It just basically didn't work well for anything that drove a lot of power. It would have been better if they would have ran a neutral wire. But again, more money running 4 wires instead of 2 everywhere. But if they would have had a neutral wire, that would have worked okay. And part of that problem too might have also been the temporary power we were on. But anyway, once I get there, I can pull some panel covers off and see what's actually going on, and I'll have a much better idea, and it'll give me a chance once I get there to do another video on power. Yay! Anyway, if you like this video, please go down, like, subscribe, comment, all that good stuff. I always like reading comments. I get a lot. Well, I don't get as many. I get a lot of extra comments through different sources. On X, and I got a few through Facebook, but yeah. Anyway, until next time, I think my next video, I'm going to be jumping back to gaming and Fallout 4 for the next video, and then we're going to be moving on to artificial intelligence after that. So that's what's coming up. Anyway, see you all later.